So what we're going to learn today, guys, is we're learning about inverse and identity matrices. It's not that tricky, but it does require some simultaneous equations and a little bit of remembering. So the identity matrix is just a matrix where everything's zero except for a diagonal starting from the top left to the bottom right of ones. So it can be any size. It could be a 2x2, 3x3, 4x4. What you see is everything's zero except starting from the top left and moving across to the bottom right. All of this diagonal are just ones. So that's an identity matrix. Now where we use this is that, suppose we want to find what's called an inverse matrix, or an inverse matrix to some other matrix, let's say A. The relationship between the two is such that if we multiply a matrix with its inverse matrix, we get the identity matrix as a result. Does that make sense? All right, so suppose we have matrix A over here. What we want to do is we want to find the inverse matrix to matrix A. Is there some sort of relationship that relates a matrix with its inverse? That. What is the relationship, Harrison?
A to the power of n equals.
The multiplication, so pre-multiplier of A with the post-multiplier of the inverse of A gives us the identity matrix. A is 5, 6, 2, 3. And inverse of A, do we know it? No. So we just say W, X, Y, Z is equal to, what's our identity matrix going to be?
1 over 0, 1.
Cool. Okay, now what's the operation between this guy and that guy? They're doing what operation?
Multiply.
Matrix multiplying. So what we can do is we can multiply these two matrices and then we can equate the left-hand side with the right-hand side. So the multiplication of these two guys over here, let's just flip the equation about. 1, 1, 0, 0. And then what we're going to do is we're going to multiply this out. It's always going to be across and down. If I don't draw my arrows, well, technically it's not any form of notation we need to show. When I don't draw them, I forget how to do my multiplication. So I start off with the top left, which is 5. Then I multiply it with W plus, moving across, 5 to 6, multiplied by W to Y. Next one, 5 multiplied by something plus 6 multiplied by something. 5 by X, and then Z. First column done, or first row done. Next column, it's going to be 2 and 3s, so 2, 3, plus W, Y, 2, 3, plus, don't need that times there. It's a bit tidier. 2, 3, and it's going to be X, Z. Is that cool? Hello.
I just need to grab my stuff.
Yeah, do you want to walk? All right. Now what we can do is we can equate what we have here. We know that 1 is going to be 5W plus 6Y. And then we also can build an equation with this element down here, W and Y, and what is it going to equal? It's going to equal 0. So we're going to get 2W plus 3Y. And so at this point, you have two choices. You can solve simultaneously using whatever method you like. My recommendation would be to use elimination, or you can use it on your calculator. I'll show you on your calculator after. Question, or are you good?
No, good.
Okay, so you think to yourself, what is the easiest to eliminate here? If you look at the W's, they're 5 and 2. There's no common factors there. But if you look at the 6 and the 3, they're related. They're related by a factor of 3. So if you multiply this 3 by 2, you can turn it into a 6. So therefore, if I go 1 equals 5W plus 6Y, this is going to be 0 equals 2 by 2 is 4W's plus 3 by 2 is 6Y's. I'm going to go for subtract. 1 take 0 is just 1. Do that. 5 take 4 is just W. And 6 take 6 is 0. So, therefore, W is 1. And hence, 1 equals 5, 1 plus 6Y. This is going to give us 6 y's are equal to minus 4. Y gives us negative 4 over 6, or negative 2 over 3. So we know 2 of our unknowns for the inverse matrix. Does that make sense what's happened? Now, if I generated 2 equations to find 2 of the unknowns, what am I going to do to get the other 2 unknowns? I'm going to do the same, which is? I'm going to generate 2 equations, solve simultaneously to find the 2 values. So, my 2 equations I haven't used are 5x plus 6z and 2x plus 3z. So 5x's plus 6z is equal to 0. 2x's plus 3z is 1. Does it matter which side I put it on the equation or the equal sign? No, you can do it either way. I don't know why I did it this way. Okay, now we ask ourselves, what's the easiest way to get elimination happening?
Times by 2.
So it's going to be 5x plus 6z equals 0. 4x plus 6z equals 2. Subtract. We get negative 2 there. We get no z's. And we get just an x. So x is minus 2. All right, using that, we know that x is a minus 2. So this is going to be negative 10 minus 6z, which is going to be z is equal to 10 over 6, 5 over 3. So we have W, X, Y, Z calculated. The simultaneous method, it's just one way you can use. If you're not comfortable with that, you can always just use the solver on the calculator. So since we know W, X, Y, Z, what is our inverse matrix, please? It's Jaff. Oh, bother. W is?
W1.
X is?
Negative 2.
Y?
3.
2 over 3. And final one?
5 over 3.
5 over 3. So what you find is that if you multiply this with that, you'll get your identity matrix. Why do we do this? Well, we're going to be doing further calculations that rely on identity and inverse matrices soon. Cool.